Hi, good afternoon, everyone. Beta, now we are starting another series, and this series is going to be the series of books. Okay. So, what will we do in this series? In this series, I am going to go ahead and give you solutions to different books so that it is helpful for your exams. Okay. So, the book that I am choosing for the day is Damodar Gujarati. And in this book, I am picking up for today chapter number 2. So we will try and do at least first 5 questions of chapter 2 in today's class. Okay. So let us try to read the first question from the book. So the first question of chapter 2 states the following. It is asking what. So what is the question? It is saying what is the, please open your books, chapter 2, Damodar Gujarati. What is the conditional expectation function or population regression function? So this is the question, chapter 2, question number 1. It asks, what is population regression function? Now, please understand that a population regression function, beta, this is a functional relationship between what? Between a dependent variable and explanatory variable. Just say, for example, if I want to go ahead and tell that how will your pocket money, how will this affect your happiness, right? How will your pocket money affect your happiness? So beta, this relationship that I will draw between pocket money and happiness, that is called a population regression function. I am trying to define a relationship between the two. What is the dependent variable in this? The dependent variable is going to be happiness. And happiness depends on what? It depends on pocket money. So pocket money will become an explanatory variable. So beta, when we go ahead and we show this relationship, this theoretical relationship between dependent and explanatory variable, that is called population regression function. Okay, let's go ahead and write this down. So please write with me the population regression function is a linear function. But it cannot be non-linear. It has to be a linear function. So it is a linear function which shows theoretical relationship between dependent and explanatory variable. So it is a relationship between dependent and explanatory variable. But whenever you write answer to such questions, you should also go ahead and you should also give the equation. So please understand this thing. If you go to the book chapter 2, then what will the book say? Suppose I go ahead and I take marks, relationship between marks and income. And I tell that this is the marks, right? And I tell that beta marks, suppose they depend on income. Suppose I want to find out this relationship that, if a person comes from high income family, maybe the family is educated and they are helping him with studies, or maybe they are putting him to a lot of tuitions, and that is why the student is scoring well, let's say. So I want to define this relationship, whether it exists or not, between income and marks. And let's say that I get this positive relationship that as income increases, the marks scored by student will also increase. Now think about this. But whenever we define this relationship, then if you remember from the book, these points, these are always average marks scored by the student. On an average, the student scores this many marks. So if you remember, kya karte the hum? We would have said that beta, if income level is 100, then given income is 100, what is the average marks scored by the student? Similarly, given income is 200, what is the average marks scored by the student? And so on and so forth. So when we talk about population regression function, we always talk about conditional expectations. We always talk about conditional expectations. So we must go ahead and write it like this, that the conditional expectation function can be represented as below. And how can we represent the conditional expectation function, beta? So E of y given xi is equal to beta naught plus beta 1 x. This is how we can go ahead and write the conditional expectation function. And from this, if I have to convert this conditional expectation into population regression function, how can I do that? So population regression function, it can be represented as this. I want to write y is equal to conditional expectation plus ui. So it will be beta naught plus beta 1 x1 plus ui, not x1, xi, beta 1 xi plus ui. So this is going to be your population regression function. Am I clear with this? This is my population regression function. So we can define here beta, that beta naught is going to be the intercept term. And we can define that beta 1 is going to be the slope term. And what is the slope? How y changes as x changes, right? So we can completely define what the population regression function is. This is the first question of chapter 2 of Damodar Gujarati. Now, beta, let's go to the second question. So question number 2. What is the question saying? It is saying, what is the difference? What is the difference between population and sample regression function? It is saying, what is the difference between population and sample regression function? Is this a distinction without difference? This is the question. Number 2. So please understand, beta. Why do we use the sample regression function? Let us try to understand that first. See, population is not always at your disposal. It is very difficult to get the data for the entire population, right? For example, if I ask you, will BJP will or Congress will, right? Which party is going to win the election? So what will you tell me? You will tell me, I cannot go ahead and I cannot find out this between the entire, I cannot go and I cannot ask it to every person who has given the vote. But ma'am, what I can do is I can take an exit poll. I can ask few people, and from that, let us come to the decision who will win, right? So, but a population is not always at disposal. You don't have population at your hand, but what you have is the sample. With some people, you can go ahead and give the final answer that who is going to win the election. Is that clear? For at least for the time being, है ना? So, beta, what we should be doing is we need to go ahead and we need to tell the difference between PRF and SRF, population regression function and sample regression function. So let us please write this down, that population regression function is the locus of conditional mean of variable y for fixed variable x. So when I pass a line through the conditional means, that is what I did. When I pass a line through the conditional means, right, of y's given x's, beta ye y nahi hai, ye income hai na. So otherwise the conditional mean can be written as e of y given x. So when I pass a line through the conditional mean of variable y for fixed x, that is called population regression function. Now, what is the sample regression function? Sample regression function shows estimated relationship between explanatory or independent variable and dependent variable. So between explanatory variable, that is nothing but your x, and dependent variable, that is nothing but your y. So when I go ahead and when I give an estimated relationship, when I go ahead and I say, acha, itne kam logon mein this is the kind of relationship. When I give that estimation, then that becomes the sample regression function. But now what you can do is just draw something like this. Population regression function, sample regression function. Draw a line between the two. Okay. Let us write down some differences between the two. So first, it is based on entire population. It is based on data of samples. That's the first difference. Okay. Second, but a population, I told you, is never at disposal. You cannot have population at disposal. So because population is not at disposal, you can only think about population regression function. You cannot achieve that in reality. So what can we say? That it exists only in conception and thoughts. But this, it exists in realism. In reality, sample regression function exists. Okay, write down the third point, beta. Third point. Now, when we talk about population regression function, then population regression function, it can only be drawn as a one line. But sample regression function, because you're drawing it from the sample, as your sample will vary, the sample regression function that you plot will also vary, right? So PRF is because it is from the entire data, it will be a unique line. Unique line. But as you vary the sample, suppose this is the sample that you collected, beta. So this is the sample regression function. But if you vary the sample, suppose this is the sample you collected, then this will be the sample regression function. Are you getting it? So as you vary the sample, the SRF line will vary, but the PRF line can only be one. So these are the differences. Now the question is asking, is this a distinction? Is this a distinction without difference? So try to understand. It is important to note that when we talk, so what is distinction without difference? It means that, I mean, you know, can we say that the two are very different from each other, or these are just two different names because one is from sample and one is from population? So you have to understand that the distinction between the two is only the fact that sample regression function is estimator of population regression function. है कि नहीं है? So to estimate population मेरे हाथ में नहीं है. तो population के बारे में समझने के लिए, to understand the population, I am using the sample regression function, right? So please note down that it is important to note the difference or the distinction between PRF and SRF, right? SRF is an estimator of PRF and sample. So this word is important, that it is an estimator of PRF. PRF is not at disposal. I don't know about anything about PRF. I am trying to estimate PRF through my sample regression function. So sample regression function is an estimator of PRF and sample observations are drawn from the given population. I hope this is clear to you, beta. So sample regression function is an estimator that I am having from the PRF. Now what I want to do is the next question. So question number 3 of Damodar Gujarati. Let us write down that question now, beta. Okay, so what is the third question saying? It is saying, what is the role? Please go back to the book Damodar Gujarati. That's the book that we use for econometrics. And this is the third question. What is the role of stochastic error UI in regression analysis? That's the third question. What's the role of stochastic error UI in regression analysis? And then it is saying, what is the difference? What is the difference between stochastic error term and residual term UI hat? So it is asking, what is the, please refer back to your books. What is the role of stochastic error term UI in regression analysis? What is the difference between stochastic error term and the residual UI hat? That's the third question from chapter 2, Damodar Gujarati. So beta, let us go ahead and have a look at the solution of this question. Try to understand. When I talk about the stochastic error term, पहले समझो फिर लिखेंगे. When I talk about stochastic error term is basically the difference between observed and expected value of y. Okay. So for example, think that beta, I have the value of y given as 100. Then I make a model. I say y is equal to beta naught plus beta 1 xi. I go ahead and I make a regression model, and this regression model comes down to 40 plus 2 xi. Suppose the value of x is, let's say, 25. Then beta, what will be your expected yi? 40 plus 2 into 25. It will be 40 plus 50, which will be 90. Beta, this is expected y, क्योंकि ये model चाहिए ना, and this is actual y. The difference between the two, the difference between actual and this, बेटा वही तो हमारा error term है. Isn't that your error term? है कि नहीं है? So that is your error term. So when we talk about the error term is nothing but the gap between the actual and the expected value. Now the question is, so now it is asking, what is the role of the error term in the regression analysis? The error term, first of all, हम समझ में आ गए error term है क्या? It's the difference between actual and estimated value. ठीक है? Now, but now you have to understand that when I talk about population, right? When I talk about population, I cannot run the model per se, right? Only sample may I can estimate the error term, not in the population, because population is not at my disposal. So in the population, what is this error term doing? This error term is very important for empirical purposes. Just for example, let us take the analysis further. Abhi kuch likhna nahi hai, I will make you write the answer. So for example, I gave you this example that happiness is a function of your pocket money. But there can be other factors which can affect your pocket money also. For example, your happiness, which can affect your happiness. For example, your happiness can be affected by, let's say, my happiness is affected by the number of holidays I get, by the travel plans that I have, right? By the weather at my place, etc. So there can be other factors which I have not taken into consideration. These factors which you have not taken into consideration, which affect your happiness, these are the factors which come as part of the stochastic disturbance term, right? They come as part of the stochastic disturbance term. So the stochastic disturbance term is important because you will not be able to interpret everything in your model. So those values which you will not be able to interpret in your model, they can be interpreted through this stochastic error term. That, okay, this is the amount of the part which I'm not able to interpret, right? So this is what it is asking. What is the role of the stochastic disturbance term? So there are multiple roles. They're given in the book very clearly. So the first role of the stochastic error term, as the book suggests, is vagueness of theory. This is the first rule. Vagueness of theory, matlab, as I told you, sometimes the theory may be very vague. I may not be sure of the omitted variables, right? So when you don't have surety about all other variables, like here, I didn't have the knowledge about the weather. I could not calculate the weather. I could not calculate the travel plans, but they are affecting my happiness now. So other variables which cannot be interpreted, for those error term is important. So you can write down that UI may be used as a substitute for all the excluded or omitted variable from the model. So if I did not consider a variable which should have been considered, then I am going to, just put it as part of the error term. But the second thing that you can do is unavailability of data, right? So now I know that, acha, ye to keh rahe ki I don't know about a variable. So there is some variable XYZ about which I don't know. Then that is part of the error term. But this is saying that I know about a variable. I know that weather will affect my happiness. I know that weather will affect my happiness, but I don't have data about weather, right? So I know that there is a variable affecting Y. So I know that there is X affecting Y, but there is unavailability of the data about X. So it will just go in the error term. Okay. So whenever these are the things, there are many other reasons given, right? That you can use it for proxy variables, and then other reasons are also given in the book. But mainly you can just say that this is the reason why you will go ahead and you will include the error term in the model. So I hope this question is clear to you, beta. The question was saying, what is the role of stochastic error terms in the regression analysis? This is available as part of section 2.4 of Gujarati. You can also read through that section, but this is more or less the answer to it. And second, it is saying, what is the difference between stochastic error term and residual term? So, but a stochastic error term is in the population. Stochastic error term, that is in the population. Right? But when we talk about the residual term, you had that is in the sample. And now I have taught you when the residual term is used. The residual term, that is the difference between the actual value of y and the expected value of y. So what I found out the value to be and what the actual value was, the difference between the two, that becomes my residual term. And I've explained you how you can find your residual term. Is that clear? So beta, this was question number 3 of your Gujarati chapter 2. I hope this is clear to you. Okay. So now what we will do is we will stop the session for today. And in the next session, again, we will go ahead and take some more questions from book and we will try to see the solution to it. If you have a book in mind which you want me to solve for some chapters, please do go ahead and give it in the comment section below. You can mention which book you want me to pick up. It can be Snyder, Varian, it can be Gujarati, it can be Hammond. Whichever book you think is difficult, just pinpoint that book along with the chapter and I will try and pick those up in the coming